Let's record the session first. Okay. 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 What are we going to learn from this nice bootcamp? This presentation is divided into four different units. Firstly, we will be discussing the fundamentals of data analysis. We will review some of its definitions, characteristics, as well as what the digital footprint means. Then we will move on to the importance of data analysis, the why and how, as well as its applications and implications. Carrying on, we will mention some of the available career choices in data analysis, the ethical considerations, the skills required, and the job opportunities. And finally, we will delve a bit more into the advanced parts of data science, where we will be discussing machine learning and artificial intelligence. So without further ado, let's delve into the fundamentals of data analysis. What exactly is data analysis, first of all? It's the process of examining, cleaning, transforming, and modeling data with the goal of discovering useful information, draw conclusions, and support decision-making. It involves using statistical, algorithmic, and visualization techniques. Uh, it also enables organizations and individuals to make data-driven decisions by turning raw data into insights, helping identify trends, patterns, and anomalies, and all in all, provide a more factual basis for strategic planning. The importance of hello. Well, the importance of the data analysis in our modern world can summed up into seven different categories. First, there's the drive for decision making. Data analysis can help businesses and organizations make informed decisions by providing evidence-based insights. And this reduces, in turn, the reliance on intuition and guesswork, which can prove to be problematic at times. It can help enhance the customer service experience. By analyzing customer data, companies may tailor their products, services, and marketing efforts to better meet the needs and preferences of their target audience. It can prove helpful to predict trends. It can reveal patterns and enable predictions about future behaviors in the market, for example. This can be valuable for industries like finance, retail, and healthcare. It can improve efficiency by means of identifying areas of waste or inefficiency. It can lead to better improvement of operations and reduce cost savings, increase, let's say, cost savings in the process. In innovation and competition, that analysis can prove very helpful for the rapidly changing innovative market. It can help a company maintain its competitive edge over the rest of the competition. It can also aid in mitigating risk. Analyzing the data may help predict and even mitigate risks by identifying potential issues before they realize themselves into real problems. And finally, in personalization, even so today, we see this in algorithms like TikTok or YouTube, where for the strategy of engagement, an algorithm is used to personalize and tailor the content to each customer's specific needs. Now we will review as fast as we can a few origins of data. Where can we aggregate data from? This may be data coming from internal company data, such as showing in the slide on the left. A few examples are sales records, customer databases, employee records, etc. These are normally data that is isolated from the internet. It's only readable from personnel inside the company or organization, not publicly available. Customer-generated data is more familiar to us, perhaps. This is data that is aggregated from online purchases, social media interactions, survey responses, etc. You can see it all up on the screen. Machine-generated data, in contrast, is data that is not produced by a person, such as before, but is rather produced by machines or computers. This includes sensors from IoT devices, telematics from vehicles, smart appliances, industrial machines, which we also discussed on our previous meeting about HMIs, if you recall. Web and social media, it includes user-generated content, web traffic data, etc. Another category is third-party data providers and mobile data. Now with our smartphones, we have, for example, location data from GPS module on our smartphone or user statistics from the apps we open up every day. Transactional data in e-commerce platforms, for instance, data coming from research and academia, such as scholarly articles, reports, and theses and dissertations. Multimedia provides a huge amount of data. Think about streaming services like Netflix or Disney Plus, gaming platforms such as PlayStation Online. All those things produce huge amount of data from their customers. Biometric data, especially during the COVID epidemic, we saw a very fast development of remote healthcare. So this may include health monitoring devices or a much more familiar, perhaps, application are fitness trackers like a smartwatch or Fitbit that tracks our everyday physical activity. And finally, we have log files, which are a bit more technical in nature. These are usually only seen by people who are employed in the computer science sector. They may include server logs, network logs, program logs, etc. And public data and open source data, such as data found in government databases like census data or economic statistics, public records and open data platforms like the World Health Organization also may store vast amounts of data that are usable for experts or for the general public. Having said the origins of the data, let's now see how all this can be categorized in order to better understand it and use it whenever it is needed. We have structured and unstructured data, which are two very big categories, and we will be analyzing those two in the next slides, so I won't go into them right now. Semi-structured data contains elements from both those two previously mentioned. Quantitative data is data that is numerical and can be measured and quantified. Think about this can also be divided into discrete and continuous data. We will explain what those steps mean a little bit later. But think about things that are measured in numbers, such as height, weight, or the number of the participants in this presentation, for example. Qualitative data is non-numerical data, on the other hand, which is more suited to capture concepts that are arbitrary, opinions, or feelings. They may include categorical data, which is data grouped into categories like yes or no responses, for instance, or data that can be ranked, like answers from a satisfaction survey. Sorry. We also have time series data that is collected at and ordered by time intervals, usually used in trend analysis or forecasting. Cross-sectional data is data collected from multiple sources at the same time. Big data is also a term that we will see again later on in the presentation. It is a term for data sets that are so large and complex that our traditional data processing applications can't handle anymore. They may be categorized by the three big V's. Those are volume, velocity, and variety. Again, we will delve into that later on in our seminar. Transactional data are data related to transactions like purchases, sales, orders, etc. And finally, web data are all those data available from the web, including web traffic data, social media activity, and so on. Now, let's focus specifically on what structured data is. If this is a highly organized and formatted form of data, which makes it easily searchable and understandable, and typically resides in relational databases. Its characteristics are that it follows a scheme, that the data is often tabular, which means that it's usually in a form of a table with rows and columns, like a spreadsheet. It is easy to enter data, query, and analyze them. And some examples of such files include Excel files, SQL databases, or comma-separated values files. Sorry. Some of advantages of this kind of data is that it's easier to search and organize. It's efficiently processed, and it's ideal for operations like sorting, filtering, and aggregating. However, they may be the rigidity of the structure may prove to be less adaptable to changes, and they may not be well suited to capture complex or nuanced information. For this reason, we also come upon unstructured data in data analysis. Those that don't follow any specific format or structure, which in turn makes it more complex and difficult to manage. Some of their characteristics are that they do not fit neatly into traditional relational databases. They may be textual, but also not. So they may include the data formats like email messages, but also multimedia such as videos, photos, social media posts, or whole web pages. This may seem obvious that means that this kind of data require much more storage than traditional text. And they're difficult to analyze using conventional tools, but we have developed more cutting-edge tools to use them recently. Some of their advantages, though, are that they're capable of capturing a wider and more varied range of information. They more closely reflect the nature of data in the real world, and provides rich data sources that can be mined for valuable insights. The disadvantages, as we said, are that they're challenging to categorize and analyze without tools such as natural language processing or machine learning algorithms. And we will discuss a bit more about their importance later on. And also they require more complex and resource-intensive processes to convert them into usable data, as you can imagine. Now, as we said, data may be qualitative or quantitative. And specifically, in the case of quantitative data, we have two big categories. They're either discrete or continuous. So what does this exactly mean? Well, discrete data points, you can imagine as separate and completely distinct from each other, while continuous data points can be infinitely close together. So, for example, think about if we wanted to count how many cars are in a parking lot, there could be one, there could be five, but there could never be 2.3 cars. There is always going to be a natural integer number. So this is an example of discrete data. Whereas if we were to measure the distance a car travels, for instance, then this value may take any number between 0 and infinity. So this is continuous form of data. More specifically, we can see that discrete data involves integers usually. Here are some examples on the screen, like the one I mentioned. They're often represented as counts, can take a finite number of values, as we said, and usually they're visually represented by bar graphs and pie charts or distinct points of data. Whereas continuous data take any value within a given range and are infinitely divisible. Think about floating numbers, for instance, floating point numbers. And those are most commonly visually represented by histograms or line graphs, as is the case for continuous functions in mathematics. Carrying on, we can see a few common data types used in programming language that regarding data analysis. We have firstly the primitive data types, which are an integer, a whole number, both positive or negative, a floating point number, which has a decimal part. Double is simply a floating point with better accuracy in exchange for more memory usage. We have a character, which is a single character, which may be a letter, a number, or symbol. A Boolean type, which represents only two values, true or false. Typically, in computer science, those are represented with a 1 or a 0, respectively. Carrying on, we have composite data types, which may be an array, which is a collection of elements of the same type, so a collection of integers, for example, or characters or floating point numbers. A string is a sequence of characters, which is usually used to represent text. And a structure is a composite type that includes a set of variables in one block of memory, but it may be from different data types as opposed to an array. The abstract data types include a list, which is an ordered sequence, a map or a dictionary, which is a collection of key-valued pairs, a set, which is a collection of unique items, a stack or a queue. In a stack, we have the fashion of last in, first out, and in the queue, the difference is we have the fashion of first in, first out when adding or removing elements. These are a bit technical terms, so we're just gonna briefly skip past them. The specialized data types are date and time, which represent specific moments in time, enumerations, and objects in class-oriented programming. We have the pointer and reference data types and data structures. Again, these are all for reference if anybody is interested in a bit more info about the computer science in general. So I'm going to move, for the sake of time, forward. Now, let's go over some of the characteristics of data analysis. What defines data analysis as a science? Well, firstly, we have accuracy of our data. I imagine anyone can guess why this is very important. precise data, only precise data are able to yield reliable insights. If we accumulate inaccurate data, then probably we will be led to faulty conclusions or decisions later on. We have the reliability, so data must be consistently reproducible under the same conditions. And relevance, for instance, if we have a big data set, we need to be able to discern what kind of data is relevant, is important for our specific project, and what data we need to disregard. Timeliness is how up-to-date is our data. We can't be making correct assumptions or decisions if our data is out of date, obviously. And completeness is the assurance that our data sets are comprehensive and are not missing any critical information. Any data set that is incomplete may result in a huge impact on the quality of our analysis. Carrying on, some secondary characteristics of data analysis are consistency, which is essentially the necessity for data to be coherent and compatible, meaning that they must be in the same format that we can use with our programs and applications. Granularity is the level of detail of the data. Think it as like definition in computer terms. Accessibility is the issue with which the data can be retrieved and used by authorized individuals. Interpretability, meaning that the data must be in a format that is understandable and interpretable by its intended users. And finally, integrity, which means that our data hasn't been corrupted by unauthorized access or someone who has a reason to cause any harm. Now we will be discussing the term digital footprint, which has been very popular in the last few years on the news or on articles online. But what exactly is this term, digital footprint? Well, digital footprint is the record of an individual's activities and interactions in a digital environment, most commonly online. This is an indelible trail that users leave when they navigate the web or engage in social media or participate in online transactions, etc. There are two big types of digital footprints. The first is active. This is the most, let's say, naive one, the less harmful in a way, because it includes data that one person intentionally submits online. So, for example, it may be social media posts or articles that the person has published or comments on forums. These are all data that is controlled by the user and that he agrees and consents to post online. Whereas the passive digital footprint is data collected without the user explicitly giving his consent and can often be logged by websites, applications, or background services. This may include the cookies found on your browser, or it may be your IP address stored in a server, or even your location from your phone. More and more data is nowadays being stored this way, and typically includes data that the user has no direct control and isn't even aware that is giving out. So it is important to be aware of such implications when browsing online and sharing our data. Now, how can a company or organization manage the different, or even a individual can manage the digital footprint? Well, it is essential from programs like this one that individuals become digitally literate and understand how to secure their online presence and protect their information. A few steps that they may achieve that are regularly reviewing the privacy settings on the platforms that you use, being aware of the information you share, or even utilizing privacy tools such as VPNs or secure browsers. For companies now that manage digital footprints of customers, they need to commit on data protection practices and even maybe comply with new data privacy regulations. Now, can we tell some of the most often challenges? Oh, sorry. Okay. What are some of the most often challenges in data analysis? We may divide them into four subcategories, starting with data quality and integrity, which includes inconsistencies and errors. Data collected from various sources may be inconsistent or contain errors. They may have missing values, or our information, as we mentioned before, may be outdated and so no longer useful. Another subcategory is volume and complexity. So we have nowadays the new term big data, which is data that its sheer volume can be overwhelming for the usual methods of managing it, and we need to come up with new processes to achieve that. We have the variety of data, which means that data comes in very different formats, and all those things need to be taken account for. And velocity is the rapid rate at which data is generated. Essentially, it's every day it's getting faster and faster. So we need to take into consideration that moving forward. The skills gap, so many people coming out from computer science universities right now may even have fallen behind on this kind of expertise. There's the need for training and development, new people into the sector. And also, lastly, we have the challenge of integration and the siloed data or isolated data. Data that, which means data that is stored in separate, disconnected databases, not available online, which makes it difficult to access them. And also integration issues when combining data from different sources. They may be written in different standards and formats, so there's the need to firstly prepare the data before doing anything